Hi guys, this is revision video part 5 of the EIS series that we are doing, and in this we are going to wind up the third chapter by discussing the couple of controls that we left out in the last session, and also we will be discussing some important points in controls audit. So taking that into consideration, we're going to go ahead discussing the two more controls. Let me quickly remind you as to what has taken place in the past. So we did talk about the nature of controls. So in the past we did mention and talk about the controls are classified into three types: controls based on objective, right? And then we have controls based on nature, and the last one we have controls based on audit. So we've already discussed about preventive, detective, corrective and compensatory controls, and in this nature we've discussed about physical, logical and environmental controls in detail. So in this segment, in this session, we're going to discuss about two controls, wherein first we'll be talking about managerial controls, and then we will be looking at application controls. Now this particular session I want everybody to be a little more alert, because this one I think you have a little more aspect to concentrate and understand how this works. So let us talk about all those points that we have to understand in case of managerial and automated controls or application controls. So let's go ahead. Here we're going to talk about the first thing, managerial controls. Managerial controls. There will be a total flow of all the controls that are going to be discussed. So we'll lead up to the very first one. It is called as top management controls. Top management controls. What are some of the controls that are to be adopted by top management controls? Controls 2 and 3, both these pertain to system development life cycle. If you heard of that concept in the past, system development life cycle or SDLC. So the second one is called as system development controls. System development controls or system development management controls. Then we also have programming management controls. Programming management controls. Okay, so these are the three types of controls that one needs to take into consideration. Then going further, we have to make sure that we maintain and take care of our data resource management controls. Data resource management controls. And then we have three more: quality management controls, quality management, security management controls, and lastly we have operations management control. Operations management. So taking all this into consideration, we're trying to now build up and understand what exactly the managerial controls mean, and in this context how do they work. So these are some of the topics which are mostly ignored by the students. So let us see how we try and understand this in terms of what exactly do they mix, why do we need those controls, and what is it all about. So first, in top management controls, we talk about four major parts. First one is called as planning. Now you know what is planning, right? Deciding in advance about a future course of an action. That's what is called plan. And in a plan, we actually are talking about how to go further in a particular area. What is it? There are two types of plans. As part of planning, we have two plans. One is called as a strategic plan. One is called as a strategic plan, while the other one is called as operational plan. Strategic plans and operational plans. Strategic plans are anything that stretch between 3 to 5 years, while something for next 1 to 3 years, that's what is called the operational plans. So the first aspect that top management has to be very much bothered about is called as planning. Then moving further, we go forward, the second top management control, that is about procuring all the resources and utilizing it in the most effective and efficient manner. You remember the term optimum utilization, that occurs by way of organizing. Organizing is all about procuring the right resources. Okay, so resources and also staffing, which is about putting the right person in the right place. It is not enough if you just put the staff, right person in the right place. What you also need to understand is that you need to also give them direction, leading or directing. Okay, so that is also the other step involved here. Planning, organizing, leading or directing, and then we have the last one called as controlling. Controlling here means taking corrective actions. So whenever you're taking corrective actions, that is what is called as controlling. So planning, organizing, leading or directing, controlling, these are the 4 top management controls. Then system development management controls. Before I explain you what system development management controls are, I want you to quickly understand this SDLC, or simply the process of system development life cycle. Now, how does the system development life cycle work? Is there any system development or software development, we need to understand what the user wants. So it's called system development or software development life cycle. As part of this, first the user needs to understand what exactly are we trying to deal with, or what exactly are trying to do. System development life cycle. Now, in terms of catering to the needs of system development life cycle, first we conduct a system investigation. We conduct system investigation, then followed by system requirement analysis. This is not very much part of a syllabus, so just have a quick understanding so that we can go back and see what controls are needed. So the thing that they did with you is that they didn't give you what the concept is, but they just asked you or gave you what the controls are in the syllabus. So first take a couple of minutes just understand this. First you try and go and understand whether the project is a feasible one, whether developing a system will make sense or not. Taking that into consideration, you do system investigation. Then we have system requirement analysis, followed by system design. We prepare a technical design. After design comes the most important step called as system development. System development, where the actual coding and other works take place. Then not only coding, the one who coded it will also conduct a test of it. Coding, and then the next thing that happens after coding is that there is a system testing. There is a system testing. Investigation, requirement analysis, design, development, testing, then finally system implementation and maintenance. Now, going by all the steps, these are called as the system development life cycle. But that's not the question. What is the life cycle? I said in life cycle stages, what are your controls to be instituted? So like whether this particular system development is really a feasible project or not, whether it's going to work or not, is it a workable project or is it a feasible project? First we have to see that. So we have to do system investigation. After we conduct or after we do a system investigation, we need to possibly understand whether the user is happy. What is the user's requirement? Okay, we are doing fine, but what is the user's requirement? What is he talking about? So requirement analysis. Then we'll go about putting up a design. Then our technical team will make up a technical design and check whether the design is fine, because based on this design only our guy is going to do the entire development. So the coder will only see this and code. Okay, so that goes in that format. The coder will code based on the design. Then once it is all developed, then they'll do testing, and then finally it will be implementation and maintenance. Taking all this into consideration, if this is the system development life cycle, this step alone, this one, system development step, coding, which is also called as programming or programming management. Programming management. In this area, that is while coding, while preparing, the coder themselves understand the design, the coder does a test for himself Coder will make sure that if there are any problems, they'll make some improvements, will make some maintenance activity. All that is also taken care by the programmer. So point number 2 and 3 are these two controls, SDLC controls and programming management controls. Now let's go back to the system here. System development life cycle. What are the controls in that life cycle? So going by the next one. First one is called system authorization. You need to have the system's authorization. Is there somebody who's authorizing? Yeah, this is a viable project. You can go with this. Is there somebody who's saying that? System authorization activities. User specifications. Because the second step, user has to tell what is this, right? The user specification activities. 3 is technical design activities. Technical design activities. Then as I told you, the next step will be development, but that is discussed here separately as programming management control, so we will not touch that right now. Technical design controls. Then an internal auditor is engaged throughout internal auditors participation. Internal auditors participation. And then we have obviously testing and implementation. So we have program testing, or whatever you develop, testing, and then finally the control is user acceptance testing. User and acceptance testing, which means the final version will be checked by the user, and only after he is happy we will be taking that into consideration. So this is what is the entire story behind system development life cycle. Now the problem is, when somebody doesn't know the life cycle, they will obviously not even know the controls. So first we try to understand the steps involved in development. That is, first you got to go for investigation to see whether the project is really feasible, is it a workable project and all that. Then after that we will go ahead and decide what are the requirements of the user, then convert the user requirements into a design, and then go proceed further one by one. So that's how this entire thing works. And in this step exclusively, the system development step alone, how is programming management going to work is also something that we will be seeing now. So in programming management, what are the controls? Let's go ahead and even see that as well. In programming management, what are the controls? So this one here starts with, first again the coder has to do a planning, because what is he going to code, in which language is he going to code, what is he going to use, all that planning. Then control, is everything right or is there any need for changing? Then comes the most important act called coding. Planning, control, coding. Then once he finishes coding, oh wait, before coding there is design. Okay, planning, control, design, coding, then testing. So wherein in terms of testing, he will test everything individually, then as a whole. So everything when he tests individually, it's called unit testing. Once a particular unit is developed, whether when he combines all the units, if all the units are working together, then that is called as integration testing. And once the whole system is ready, if he is testing the entire system, that is called as system testing. So if you understand what this goes by, planning, control, design, coding, testing, and finally we talk about making any changes, maintenance. How do you go about doing maintenance? 3 things here in maintenance. If the system is already working fine, you want to improve that and make it better, that's called perfective maintenance. It's called perfective maintenance. Or when there is something going wrong and you want to change that, that is called as repair maintenance. And for changes to take place in the environment, when you want to make any corrections or updations, then that is called as adaptive maintenance. So top management controls, system development management controls, programming management controls, all these are the set of controls that one needs to take into consideration while system development. First one being top management, this 2 and 3. I hope now you understood the background of SDLC, system development life cycle, and these controls are surrounded across the life cycle, and then the programming management. Okay, now we all know that most of the times we maintain data in the data warehouse or database, So how do you manage those controls? The database. At the database, what are the data resource management controls? Again here, first, what data is being maintained? The data definition controls. Definition controls. Data definition controls. What exactly is the data? Then comes backup controls. This alone can be a short answer question, guys. What are the different types of backup? You can do one thing. You can do two recordings at the same time of the data. It's called dual recording. Dual recording of data. Same data can be recorded twice, so that it is in one place. The original data, one more copy backup will be there. Dual recording of data. And then we have periodic dumping, like how once in a while we take backups to pen drives or we take backups to hard drives, like that. A periodic dumping. Dual recording of data, periodic dumping. Then we have logging the changes or logging the inputs and then logging the changes. But logging on its own does not work. You take a periodic dump. When you take a periodic dump, that is how periodic dump plus logging the changes after that. So when you are restoring, you will restore the periodic dump first and then restore the log, so that the entire data up to date will be coming. So logging of changes, which is what we need to try and understand in this context. So yes, then we have the next one. Who are we giving access to the database? Access controls. Access controls. Then we have update controls. Yeah, who is going to update the database? Access controls, update controls. And then we have one very important control. Now, like data is there in two places. Same data is there in two places. If data is being changed in one place, the same change should take place in the other place also, right? That is called as concurrency controls. That is called as concurrency controls. Concurrent means at the same time. So concurrency controls. And finally, making sure that data is maintained with the quality. It's called as quality controls. So taking care of data, keeping it in its original form, that's the best thing that you can actually do about. So yeah, it's a slightly broad topic, guys, this one. So we have to go slow and try and understand what exactly it is. So all these controls are established by the management. That is why they're called managerial controls. First of which is top management controls, system development, program management, data resource management. Fifth one is the most easiest one, which is called as quality management controls, which is nothing but matching quality standards. So there are some quality standards that we work with, right? So matching with quality standards. Every time you do something, you want to match with something, that matching the quality, that is what is called as quality management controls, to make sure that, see, later after everything is established, you should not say this is not proper, that is not working well and all that. So matching quality standards. Security management controls are nothing but the same controls according to the nature. You know, we talked about environmental controls, physical controls, logical controls, all these taken care, plus insurance and disaster recovery plan. All these are considered as security management controls. So 5 and 6 are more to do with something that you already saw. 5 is just the idea is to maintain quality. 6 is about a couple of things wherein the same dangers are discussed in security management control. First, where are the threats coming from? Threats are coming from fire, water, pollution, or maybe by physical theft or viruses, worms. So for all those different type of threats, we have physical, logical and environmental controls to safeguard them. Now comes the last and the 7th one, operation controls. So if somebody is making this chart along with me, for you can have the 7th one here. They're called as operation management controls. Operations management controls. On a day-to-day basis, what controls will be maintaining as a matter of day-to-day operations to make sure that everything is smooth. They're called computer operation controls. Making sure that computers, both the operating system and the application softwares, are working properly. Computer operation controls. Then making sure the network works properly, that's called network operation controls. In computer operations, the idea is to make sure that the operating system, application system and all the programs that you loaded, hardware, software, everything is working properly. So is the case with network. Is the network available all the time? Is it up all the time? Are there any changes that we make to network routing? It's network's resilience. You remember the word resilience? Its ability to recover from crashes. So how good the network is. All these are some things that are recorded here. So computer operations, network operations, then care against data preparation. Because who's preparing the data? What is it about? And then two libraries: a file library where everything is maintained, and then comes a document library, file library and document library. These two are there is a librarian who is in charge of maintaining all the files in one place. So unwanted files are removed, wanted files are safeguarded for longer, all that is taken care. And then they should have a help desk function, so that anybody who is not able to use the system, who is in any kind of grievance, he should be able to use the system, help desk. And then we have capacity planning, so that the server doesn't collapse and say page not found and all that. 404, you find that error. So that is not because of some server missing or something. There is too much load that right now the server is unable to handle, and that's only because of poor capacity planning. Capacity planning. So if the capacity is planned properly, all these issues will not happen. It's called traffic management or capacity management. And then the last one is called as outsourcing management controls. Outsourcing management control. So whenever something is being outsourced to some third party, whether the third party is working on it well or not, if the third party has control over data, then it's a little task for you to be afraid of, because what if they take the control of data? So you might want to take care of all these points. These are all called the operation management controls. So yeah, this is exactly what the entire set of managerial controls look like. Let me take you back to that. So it's a very important part, guys, this one, the managerial controls. Yeah, I understand it's a little extensive, but I think you should try and understand, keeping it more simpler and easy on how it works, what does it do. Okay, so if you want to take a screenshot now, you can take this one and the next one. I obviously am also showing you the next one. And that will take us to application controls. Let's move on to the next part. Then the last part of controls, these are called as application controls. They're called as application controls. Now 6 application controls are there. First one is to make sure whoever is entering the data or whoever is giving the data, everything with respect to them is fine and safe. So procure a control which is called as the boundary controls to safeguard our boundary, so that unwanted or unauthorized people do not enter. That's called a boundary control. And as part of boundary controls, you have what is called as password, making sure only people who know the passwords can enter passwords, PIN, biometric, passwords, PIN, biometric. Then you have the most important thing called cryptography. Okay, and ID cards. Remember ID cards? We talked about all of them in the past only in physical controls. Along with that, we also have what is called as cryptography. The study of cryptography. Cryptography is about two things. Cryptography is about encryption and decryption. Now, what do you mean by encryption and decryption? Cryptography is a study. Encryption is a process of converting. Encryption is a process of converting plain text. Converting plain text into ciphertext. Ciphertext means the codes. That is what is called cryptograms. Okay. And converting ciphertext back into plain text is called as decryption. And this is done by somebody who is called as crypt analyst. Crypt analyst is the guy who does that. And there are 3 methods of doing cryptography. One is called as substitution, where one letter is substituted by another letter or digit. Then we have the next technique is called as transposition, where we shift the positions. And third one is called a product cipher, where we do a combination of both. So that is what are the techniques in cryptography. So if you're reading that piece, read this carefully. This alone can be a short answer question. So that is what the first set of control that we spoke about here. They're called as boundary controls. Then we talk about input controls. We also have processing controls. Now normally this is working of an application software, right? Take the input, processing, then if it's transferred from one place to the other, wherein it's called as communication controls, over the network communication controls, to make sure it's displayed to only authorized people. And then we have input process, we obviously have output and storage. Storage are called as database, that is a place where we store, so database controls. And we also have whom to give the output, only to authorized people, output control. So let us try to understand more about this by elaborating first at what are the input controls. Now first and foremost input control that we're talking about, which make sure that everything given as an input is safe and secure, is called as source document controls. Protecting a source document becomes very important. Okay, source document controls. Source document controls are nothing but the original documents from where the entire data is given. That source has to be safeguarded. How do you do source document controls? You can use pre-numbered documents, using pre-numbered documents, and you can also use source documents in order. Use source documents in sequence, and these kind of source documents could be kept in safe custody, and periodic verification of source documents also will make a lot of sense. Then we have the second type of input control. While typing people make error, they are called as data coding controls. Data coding controls are to avoid mistakes of addition, truncation, that means you are cutting off one digit, transposition, shifting one to the other, transcription, transposition. These are two types of coding errors. Why data coding controls? Because there are errors. And what are the errors? If you see, there are two types of errors: transcription, and then the other one is called as transposition. Transcription errors and transposition errors, these two are to be taken care and rectified. Then we have what is called as batch controls. We have manual batch and electronic batch. Batch is where a bunch of transactions are processed together at once, so that is called batch controls. And then lastly we have whether check, just final check whether whatever input we gave, is it valid or not. That's called as validation controls. So all these are some of the controls to make sure that the input that we gave is safe and secure. Boundary controls, input controls, okay, to make sure that what we have, we'll get back to processing, output and database controls. Meanwhile, if we are giving data as input, it has to be processed elsewhere or in the local system. Data travels from one place to the other, right? So that is called as data communication. And in communication, across the communication line, there can be something that can go wrong. Protect the user. First of all, to protect user, we have boundary controls. Then to make sure that we don't give wrong inputs, we have input control. That is right from the source document or using pre-numbered source document, wherein we are actually giving the data very clearly and making sure that there are no coding errors. All these are something that one needs to take care of properly. Now after taking care of all these properly, we need to make sure that whatever we gave as the input only has reached the processor. While processing, to avoid any mistakes, while processing we have processing control, but to help us reach till there, we have communication control. So we have to protect the communication line. The first set of controls in communication controls are line error controls. Line error controls, which are to just make sure that something across the communication line doesn't go wrong. Anything across the communication line doesn't go wrong. So what you do is, that's why we do test communication. We send from here to there to see whether the communication aspects are working properly or not, or how they are working, who is on the other end, whether they are receiving or not. So you send and receive back. So to say, okay, this is safe. Now without any errors, line error control. Then we have very important flow controls. You know why flow controls are important? Because let's say if I am a higher bandwidth computer and the other side is a lower bandwidth computer, I am able to send so much data, but the other one is not able to receive so much. When the other one is not able to receive so much, the next thing that happens there is that there is so much space on the web, wherein right now this data waits across, because I am sending it from my system, it has to reach the other system, but since it's not reached the other system, it is waiting over the web, and that gives a potential way for intrusion for somebody. Those are called flow issues. So to sort flow issues, to pace both of them at same speed, like we have flow controls, so that no data waits on the network to be distributed and something goes wrong. Then we have link controls. Link controls are about, in the past session I told you about LAN, MAN and WAN, from one area to the other, local area network or wide area network, how they are connected and what that's what is called a link. So link controls take care of two things, the connection between one area to other. If it is a shorter distance, it won't be a big deal, but when it's a bigger distance, that's when all the problem arises, and that's where we need these controls. They're called as link controls. Then how to connect to a communication channel, they're called as channel access controls. Now if you let so many people access your communication channel at the same time, there will be too much of load. You remember the word contention that I told in my previous session? Yeah, there is sometimes one way where everybody fights to attain the same thing, that's called as contention. But there is also one more technique where everybody gets access to resources one after the other, that is called as polling. So polling and contention are the two methods by which somebody gains access to a channel. So make sure that channel access control, should you use polling or contention techniques. And the last one, these are called as inter-networking controls, and these are totally meant for going on the web. Inter-networking controls, wherein you are using various devices and all those are taken care or not. So application controls consist of boundary controls, 1, 2 input controls, 3 processing controls. 3 communication controls. Now let's look at 4 processing controls, 5 data controls, and 6 the output controls. I'm taking you to the next page, wherein, so I hope if you have a horizontal book and you have space, you can fill in. I am going with the next ones here, wherein application controls continued. Application controls, the continued part. We are having 3 more branches. 4, what is the fourth one called as? Processing controls. It's called as processing controls. And then we will get to the database controls. Who will manage the database? That is, who will make changes to the database and who will update the database. So we have control there. And then controls over output, to make sure output is viewed only by authorized personnel. Let's see how that works. Processing controls. First, take care of the physical hardware that is processing. So sometimes if the processor, that is a CPU, is not properly configured or it's not properly working, then the entire activity will go waste. So first take care of the physical processor controls. Processor is nothing but our CPU. So make sure that the CPU is taken care of. Processor controls are installed. Then you remember the 2 memories that we spoke about. One is where the entire data is working on RAM. That's called primary memory or real memory controls. Then we have virtual memory. When RAM runs low on space, move the data to the virtual memory, right? So to make sure that the system doesn't collapse and it moves from the RAM to the paging file and paging file back to the RAM, we establish controls called as virtual memory control. So we have 2 controls here, real memory controls and virtual memory controls. Real memory and virtual memory controls, the 2 types of controls established out there. And then we have what is called as data processing controls, just to ensure that outputs are complete and accurate. The data processing controls are set up and installed. So making sure that the processor controls are nothing but or processing controls are nothing but once the data is given input and it is communicated to the processor properly, After data has been brought to the processor, whether it is taking that into consideration properly or not, that's what we deal in a processor controls. Okay, then going up now, data storage, two very important things. Already if data is there inside the database, who will update that? So under database we have update controls. Database control the classified to update controls, and then once the database is updated, we have retrieval from the database. So report controls, what all can you pull from the database? Report controls. So there are two things here to discuss: update controls and report controls. Who can update the database, or whether the database is updating properly or not? Everything that occurred in the regular systems have been updated to the database or not. That is done using what is called as sequence check. Whether everything is in sequence, whatever transactions in whatever order they happened, in the same order only were they entered into the system or not, we do that check. That is called as sequence check. Then the second one is called ensure all records are processed. Ensure all records are processed. So, you should make sure that all the records are processed, otherwise one or two getting missed out, not getting updated in the database shouldn't be there. Which is exactly why what were yesterday's totals and what are today's totals. Like any totals or any numbers, or yesterday so many files were there, today how many are there. It's not just to note, but it's better to also print and keep that. It's called print run to run totals. Print run to run totals and keep them. I hope you have already an understanding of these controls and you're trying to recollect and understand that. And then print whatever suspense account you got to maintain for all those unprocessed or unupdated items in the database. They'll have to go to the suspense account. Okay, so this is about the update controls. Then we're talking about report controls. Master data or standing data. Make sure that only authorized people have access to master data. Any changes made to the master data or standing data has to be done only by authorized personnel. Then I'm just curious. One second. Wait. See these two, printing run to run totals. These are okay. These two are report controls. Just a second. So here, okay, wait. So small change. Yeah, update controls, ensuring that there is a sequence check, ensure all records are being processed. Then multiple transactions processed properly. So there are multiple transactions pertaining to the same record. Multiple transactions processed accurately, because when multiple transactions are occurring the same, so let's say same product is sold for so many times, the same product code is repeating, whether it is taken care properly, and you have to maintain suspense account. For anything that does not go anywhere and it does not follow, it's going to maintain a suspense account. And then once you maintain a suspense account, print that suspense account. So take care of standing data, print the run to run totals, print run to run totals, and also print suspense account, print run to run totals and print suspense account. And the last report control is to make sure that whatever updates you make or backup recovery controls, tomorrow if something happens in a database, there should be existence, or it's called existence or backup controls. Existence or backup controls. So whenever there is anything going wrong, you get back that is called as. The same existence, the backup control be used for output also, because when output goes, you got to get back that also. So but making sure in output, you have to make sure that storage of sensitive forms in whatever form, like bill books or any invoices, wherever updates are coming out, they should be kept under lock and key. That is called storage of sensitive critical forms. Storage of sensitive critical forms. Don't let everybody and anybody access these sensitive documents or data, because what if the letterheads or bill books are in the hands of wrong people? Not only that, logging of output. To whom did we give the output? Where did we give the output? Where was it displayed? What is it all about? Logging the output. Then spooling. You remember what is the abbreviation for SOOL? Simultaneous peripherals. Simultaneous peripherals operating online. That is what is called as spool. Spool means simultaneous peripherals operating online. And when they are operating online like that, what is the thing, So printer to computer, there is a connection. We send lot of computers may be connected to the same printer over the network. Everybody may send the data for printing, but when one print job is executed, other peripheral will wait, or simultaneously all of them are operating online, but till the one print job is completed, the other print job will not start, right? So there you have to wait for the print job to start, and meanwhile when the data is waiting across the network, somebody should not be able to see what is going on over the network, or somebody should not be able to have the access to this data when data is waiting over the network to be printed. So that's spool, or spooling is a technique of maintaining a queue. Spooling is also called as queuing. Okay. Storage of sensitive critical forms, logging of output, spooling, and then we have controls over printing. Controls over printing. Who should print, where they can print, what they can see, what they should and what they should not see. Controls over report distributions. For major parts of the organization, reports should not be distributed to everybody. Only if some report is to be seen only by CEO, it has to be given only to him. So such controls are called as report distribution controls. And then here also we have retention controls. So for how long will the output be retained and for how many years? Now that depends on use of the output, need of the output, or even laws and regulations will prescribe. Like say books are to be maintained 8 years, books of accounts. Documentation to be maintained for 7 years. So where law says you maintain for those many years. If you want to keep for more, you can always keep for more. And the last one is the same control. It's called existence or backup controls. Existence or backup control. So all these are the controls that are pertaining to the application controls. So yes, this one is also a little extensive, but yeah, you need to try and understand. Guys, honestly, if somebody has skipped this topic, they didn't study this, it's not a very difficult topic to study. You can try and study it once and then get back here to try and understand what I told. Or if you already decided to skip, then there is nothing that I can really do at this point of time. Okay. So taking you back to the nature of controls, that's the end of the controls topic. So preventive, detective, corrective and compensatory, these four are control based on their objective, while based on the nature we have physical, logical and environmental, and based on audit we have these two managerial and application controls, which is what we saw in detail. This is the managerial control part and this is the application control part. Okay, now coming down to the last topic for our discussion in chapter 3 in the revision series is called as information systems audit. Information system audit. Now there are enough reasons why you have to do audit, because if there is a organization's cost of data loss. If the organization loses data, that will be costly for the organization. If the organization is not maintaining something properly, then it leads to several things. And if system is not developed properly, system development controls, and the system is not developed properly, then that can lead to a problem. So like this, there are a lot of reasons why you need audit. So we will look back at the overall need for IS audit, need for information system audit. This could be a short answer question. So we'll discuss these 7 points and then go on to discussing a couple of small topics. Yeah, one, as I said, if the organization does not maintain these controls and they lose data, that could prove to be very costly for them, and that is what is called as organization cost of data loss. Organization's cost of data loss. And if you don't have proper audit system, you go with wrong data, and that can lead to incorrect decision making. Computer abuse, the cost of computer abuse. There is nobody to check who's doing what. So somebody is there who's misusing the computer, cost of computer abuse, value of computer, the both hardware, software, people. If the value of all these are high, and then obviously you need to protect them, right? So that is exactly, again, you need to do audit. And if you don't do things in audit, high cost of error. In audit, you have to find out these errors and rectify them, and if you don't, it could lead to a high cost of error. And then you want to maintain privacy, maintenance of privacy. That is the other reason why you have to do the audit, because if data is not kept private and data is made public, confidential data made public could prove to be other serious aspect. And then the last point here is about computer use. So now that the computer use has become rampant, people are using it from anywhere and everywhere. Then you can ask me, sir, that's a good thing. No, yeah, it was a good thing. It's also an advantage, nothing to do with that. But having said that, taking into consideration all that, we do have a problem here that if the computer's evolution is so much that anybody can sit from anywhere and hack, then I need to install controls and make sure that whether those controls are there. So all these 7 points are strongly telling me why I need an audit. Not only that, to make sure that this audit works well, we have something called as concurrent audit tools. We have concurrent audit tools. Okay, what are the 5 concurrent audit tools which are very important? Now this again is a star question that can come up in the exam, one of them or all of them. Let me take you through all the 5. First one is called as snapshots. As I told you, we have 5 tools. Snapshot, let's take one at a time and go with the first one. Snapshots, you know what they do? See, in computers, what is the starting point and what is the ending point is visible, right? But what exactly happens with the entire system, that probably might not be visible because of the lack of entire audit trail. Now snapshots are such softwares which are embedded. All these 5 whatever we're discussing, they're all called as embedded audit softwares, okay, because they're embedded very much into the application system. And since they are part of the application software, they'll capture the entire flow as to what happened. That is what is called a snapshot. A snapshot is about helps in what? Tracing a transaction completely. Tracing a transaction from start to end is not possible. So what it does is you specify the criteria. Every transaction that is above 50,000, I want the entire flow of the transaction. The snapshot will capture the entire flow of transaction and bring you. That is what snapshot does. And then it will park it in a snapshot file. Now you go there as an auditor, pick up that snapshot file and review that file completely. That's what is about using a snapshot. What is snapshot? An embedded audit tool that is very much embedded into the application software, where it will capture the entire flow of what happened, and then the auditor can review those snapshot files. Then the second one is called as integrated test facility. Integrated test facility, which is also in short called as ITF. In ITF, what we do is to create a dummy unit of the original system. Now like say original application system is there, we create a dummy unit of the original application system. We create a dummy unit of the original application system, and where the original application system, this dummy unit will totally replicate that. Okay, it will totally replicate the original system, and since it's replicating, we will now post transactions to the dummy unit and see the results. Now here, like when you buy a calculator, what do? You try with some known questions, right? 4 into 3, 12, 4 plus 3, 7. Whether you are getting, you will give some known inputs and see whether you are getting the outputs that you know. Same way in ITF, test data is prepared for which you already have answers, and that test data is tested in the dummy unit, and you see the results of the dummy unit and you compare with the results that you documented. You see if they both are same, that means the main system is also working. This dummy unit is a replication of the main system. So what is the thing here? Create a dummy unit. Okay, create also test data and This test data is put up onto the dummy unit and results are compared. Results are compared. That is what the integrated test facility does. That's another embedded audit tool. Snapshot, ITF. The third one is called SCARF, System Control Audit Review File. System Control Audit Review File, SCARF, which is also just like the snapshot. The snapshot only captures the entire flow of the events, right? It only captures a picture of the entire thing. But SCARF is more like snapshot only, but not only that, it collects a lot of data that you tell. So much of it. It talks about who did it, when they did it, what time they did it, not just what happened, but also everything surrounding. So SCARF can be called as, snapshots plus extended records or extended data collection. So snapshots plus extended data collection, that's what SCARF is all about. So SCARF is more in detail, while snapshot gives you only that data, right? SCARF is more in detail, it's more extensive and more elaborate. Then we have another tool called as CIS, which means continuous and intermittent simulation. Now we have two things here, like say I'll tell you here, we have the main unit, okay, and we also have the CIS unit. Now let's say a transaction occurred in the main unit, a transaction. When the transaction has occurred in the main unit, the same transaction is pushed to CIS. But CIS, will have a criteria, check every transaction about 20,000, 50,000, whatever criteria is set up. So if it matches the criteria, it will check that, otherwise it will push it further. Now, what happens is, CIS, if it matches the criteria, it will provide an answer, okay. Main system would have already provided an answer, you compare these. If they both are same, absolutely perfect, you'll go further. If these two are not same, then this, whatever is the reason of that is not being same or something is not same, that will be put up into a exception log file. Exception log file. It's also a log, a chronological record of all the exceptions that took place in these kind of systems where now like say for example, a main system did a transaction, it got the answer as 10. Where the same thing was processed in CS, the answer is 10. No problem, transaction will be recorded. But when this is 10 and this is 9, where there is a difference, what is the difference, where is the difference, all that will be loaded to exception log file. As an auditor, when I go, I will pull out the exception log file and conduct a complete audit of what all are those transactions that got recorded in the log file. This is also another audit tool. Snapshots, ITF, SCARF, snapshot, we have ITF, then we have SCARF, CIS, and the last tool is called as audit hooks. Now audit hooks are again some kind of a embedded audit tool, or they are also a concurrent audit tool. What they'll do? They will flag all suspicious transactions. They flag all suspicious transactions. Flag in the sense here they highlight all the suspicious transactions, whatever transactions are not doing fine, or where there's like say for example somebody in a insurance company, they change the name of the beneficiary and immediately withdrew funds, which could be truth also, but consequentially when there is a change in the name of the beneficiary and immediately somebody is withdrawing funds, don't you think there is something to suspect? I am not saying that is wrong, right, but is there something to suspect? The one who got it changed to his name might not be the actual beneficiary, and every time something like this happens, it triggers a doubt, is it working properly or not? So you tell all those suspicious acts to the system, audit hooks will maintain a list of that, and whenever something of that sort happens, it will flag such suspicious transactions and send it to the auditor, so that the auditor will conduct a review around those. What are these 5 called as? They called as concurrent audit tools: snapshots, integrated test facility, SCARF, CIS, and audit hooks. Then moving further to the last topic that I want you to have an understanding is a very small but a very important topic called as the audit trail. You have the concept of audit trail. What is audit trail? Yeah, let's talk about it. What is audit trail? Audit trail is nothing but tracing a transaction tracing a transaction from beginning to end, start to end of a process. If you are tracing a transaction, what is the starting and what is the ending? A well defined beginning to end, that is only called as an audit trail. It's a complete record. It's in fact it's a chronological record of all the transactions that take place in the system. That is what this is all about in terms of understanding what audit trail is all about. But the question is, why? What are the objectives of audit trail? Why are you maintaining this audit trail? See, does it maintain a track of all the transactions that are happening? So tomorrow if something goes wrong, who did that? When did they do? What happened? And if this event happened, can I rebuild these events? So like that, if you try and understand what exactly it is, or when a list of all the activities are being maintained, if anybody unauthorized gently steps in or jumps in, what is it they're trying to do like that? So objectives of audit trail is to detecting unauthorized access. See, it maintains the list, guys, like this. So username so and so logged in, username 2 logged in, username unknown user login found. So can you detect unauthorized access or not? That is what is called as detecting unauthorized access, because you are maintaining this log. Just like however security guard at our apartment, the premises maintains the register, who came in, who went out, a log register. Same thing like that here. You maintain a log register to detect any kind of unauthorized access, detecting unauthorized access, so that, but it's only a detective control. It doesn't stop somebody from entering. After entering, it maintains a record so that you can make some correction or change later. Detecting unauthorized access. Then when there is, now 1, 2, 3, 4, everything happened in a sequence, right? 1, 2, 3, 4, 5 like this. What happened? Where did it happen? Where were the changes? What went wrong? All this. Now let's say something went wrong and you want to redo the whole thing. You can see the audit trail and rebuild the whole thing. What is it called as? Reconstruction of events. Detecting unauthorized access, reconstruction of events. And will I have a little tension that my name will be recorded in the audit trail if I do something wrong? In my previous segment, I told you about CCTVs. CCTVs generally only show you the footage after the theft has happened. But if there is a CCTV over there, then I'm like, alright, there is a CCTV over there, I should not steal. Does it also scare you a bit? Same way here, audit trail also acts as a preventive control, whereby like, array, my name will get recorded in the audit trail, let me not do this, I will become accountable for this. So like that is called as personal accountability. It makes you accountable for whatever you do. So that is where personal accountability is also one of the points, which is why we need to set up the audit trail. Understood? Audit trail is a record of all the transactions, tracing the entire transactions. And please do read this question in detail, guys, because this is also a question that has come in the exam in the past. What is audit trail and what are the objectives? Now also you can read it and make an understanding of what are the objectives. So tracing a transaction from starting to end, that too in a chronological order, that is what is called as audit trail. And yes, it will help you detect unauthorized access. You can reconstruct all the events and it will help you maintain personal accountability. That is also something to do with the objectives of the audit trail. Also, one small last concept I'm not going to explain in detail, just give you an insight about is segregation of duties. Do not give one person a complete control, because giving one person a complete control will destroy the whole activity. So what you need to do is segregate the duties. Okay, segregation of duties is another short answer question. Making sure that one person does not have the complete control. Custody is with somebody, records are with somebody. So, but yeah, of course, if they all collusion among employees and inherent limitation in internal control, right? So just also take note of that short answer question called segregation of duties, where the theme is not giving one person a complete control. Don't give one person a complete control. It can prove to be a big damage. So that is exactly what you're supposed to do. That is why we talked about role based access. Give them whatever they need only based on their roles. Let them assess and do it accordingly as per their roles and not as per what they want. So that brings us to the end of this session, guys. We discussed about 4 very important things, 4 or more here. We talked about managerial controls in detail. We talked about application controls. I do understand that it's a little tedious session, this one, because there is so much to get into your head. And then we did talk about audit, why audit is necessary, and then what are the tools that are involved in doing concurrent audit, and finally the 2 small concepts of audit trail and segregation of duties. That brings us to the end of chapter 3. It's a big extensive chapter covering 3 parts, so that is why I also split it in 3 parts and we did this. And in the next part of the revision video we will be talking about e-commerce, wherein we are going to talk about e-commerce and digital payments, and then we'll move on. There's a schedule. Chapter 4, 5 will soon follow up in the next revision videos. I will see you soon again.